All right, let's take a look at this guy. Let's see. A 16 kilogram object going this speed is stopped by a force in 0.125 seconds. What force? Okay, so I think this one is going to be... this one's going to be Suvat first. Here's why I think so. And then it's going to be F equals ma second. Here's why I think so. Because we only have the mass. We don't have the acceleration or the force, right? But we have a bunch of kinematic stuff. So let's do that. S-U-V-A-T. I bet what we want to do here is find the acceleration. Then we can plug it in for A, right? Okay, so let's see. It's going 23, so that's the initial velocity. It's stopped, so the final velocity is 0 in an eighth of a second, right? And so we want to find the acceleration. We don't really give a hoot. I'm sorry to use strong language there about the S, right? But we do care about the acceleration. So we're going to go V is U plus AT. So 0 is 23 plus negative, whoops, A. I was going to put a 9.8 there. I'm getting spacey. Okay, 0.125. Ignore that negative. Okay, 23 divided by 0.125 is, the acceleration is negative 184 meters per second squared, right? So now I'm going to plug that in to there, right? So F equals 16 times negative 184. And we get that the force is negative 2944 newtons, right? With 2 sig figs, that'd be about negative 2900 newtons. And of course, the minus sign means that it's opposite the direction of positive. It's opposite the direction the car is going. But notice that this force is stopping the car. So it makes sense that it's opposite the direction the car is going. That's what that means. That force is backwards.